So my name's John Kerr. I'm Trading Networks Manager for Zero Carbon Harrogate, and we've partnered with North Yorkshire County Council, or sorry, North Yorkshire Council, to deliver a local energy advice demonstrator programme. A kind of significant part of that is to develop skills within the existing construction industry within North Yorkshire. And we're offering fully funded training courses for a whole host of disciplines. And what I would ask is people, if they're interested in that, is to go to our website, go to Retrofit funded training, and it will give you a full list of what we're offering, and how to access that funded training. Obviously, if it's not something that you're interested in, if you do know anyone else that may be benefiting from that, that would be absolutely brilliant. So that training involves everything from renewables, so it's MCS credit training for various renewables, from solar PV to air source heat pumps, through to energy storage systems, or to you and I, home batteries. So it's quite a selection. And then going on to what I call retrofit professional, which is retrofit assessment, retrofit coordination, and indeed designer. So we're funding courses that are delivered by the Retrofit Academy and also Elmhurst. So there's a whole host of training there. This webinar, and indeed the series of webinars that we've been delivering, so there's one previous last week, so I'd urge you to check out our YouTube channel, which has got that recorded, and indeed this one will be recorded. So it's, again, trying to raise the level of awareness around important factors within retrofit, airtightness being one of those, which is critical and sadly, well, is emerging now, and hopefully will become a much higher prominence in retrofit, very much at the start, rather than where traditionally airtightness has been brought into. I'll hand you over now, without any delay, to Diane Hubbard, who's a leading airtightness specialist in the UK, and runs a company called Green Footsteps Limited. So again, it's worth checking out Diane's website. But I'll hand you over there now to Diane. Diane, thank you.
Great. Thanks very much, John. Can you all hear me okay? Hopefully.
Yeah.
So just to give you a little bit of background on myself, I really got into this through research, to be honest. My background is I'm an engineer, and I thought I was going to go into renewable energy. And then I realized that buildings are really key to what we do. And actually, our older buildings are really important, and understanding our older buildings. So my academic research area is pre-1900 houses and ventilation and moisture and all that sort of stuff. And that research has sort of led me on a route where I realised that actually how we analyse our buildings is important. So I became a passive house consultant. I do airtightness testing and infrared thermography. And because ventilation is important and relates to the our needs relate to the airtightness side of things, I'm also qualified on the domestic ventilation side of things. So that's sort of a potted history of where I am and why I do what I do. What I'm actually going to talk about this evening is I'm going to give you some background as a contractor. I'm going to talk through, well, what is an airtightness test? I appreciate some of you may have been present for an airtightness test. I'm going to cover explaining what the numbers are, giving us some context for that. When is the right time to actually test a building, and how to prepare for that test, really. The thing I'm not really going to talk about is, this is where you stick a piece of tape. This is how you stick the pieces of tape, right? Or you use a membrane, or you use a gasket here, right? Because in lots of cases, well, that should be specified for you as a contractor, right? In some cases it isn't, but if we're talking about wanting to achieve a good standard, then you should have specifications provided. There's also a lot of material out there that tell you how to properly stick a piece of tape onto something. So that is what I'm not covering here. But I think the structural side of it is is actually more important than that, because you've got to know some clear things about what you're trying to achieve. Because if you don't have a structure for your whole for the whole strategy for the building, then you are you know, it's unlikely to succeed, really. So that's what the presentation is covering. We'll have an opportunity then to talk about things, so we can explore, how we can explore the tape side of things then, if you want to do that. But you have to appreciate I've only got a limited amount of time, so they're the boundaries that I've put on this particular presentation. Okay, so what is an airtightness test? So airtightness is all about unwanted ventilation. So what we what it actually what airtightness is it's putting a number on infiltration, this unwanted ventilation, the uncontrolled stuff. So the picture on the left-hand side illustrates the routes that we might be talking about in a typical existing building. And on the right-hand side, we've got an example of a blower door mounted it's in a grade 2 listed building there. So I'm talking specifically this evening about using a blower door as opposed to the pulse test, which you may also be familiar with, which is approved for testing new buildings. The pulse test is quite a swift test. But the thing you're unable to do with a pulse test is to actually do any diagnostic work on the building. So to look at where the roots are, it gives you a number and that's it. The pulse test is basically, it is a pulse of compressed air that's released into the building, and the air tightness result is calculated from how quickly that pulse decays away in the building after it's released. So it gives you a result, but it doesn't allow you to explore the issues that you have. And when we're looking at retrofit and trying to spend money wisely on retrofit, you need to understand what you're dealing with, really. So pulse testing has a role. It has a role with new building, and it also has a role with some existing buildings. For example, if people are trying to make sure the building remains quite leaky, to be honest, which is the case with some of the work that's taking place under some of the funded schemes, where there's a concern over things becoming maybe too airtight, where basic ventilation intermittent extract is being used. So it does have a small role in existing building testing, but really the blower door offers lots of options for allowing us to examine what's happening in an existing building. So what the blower door does is it creates a pressure difference between inside the building and outside, and that pressure difference is 50 Pascal. That's sort of a 20-25 mile an hour wind. The same pressure difference as a 20 to 25 mile an hour wind. What it does is so it's not a crazy pressure, but unlike when the wind blows, on the windward side of the building, you would feel the draft coming in through the leaky window. You wouldn't be aware of what's happening on the leeward side and the air leaving through the leaky door on that side. What the test does is it allows you to compare all characteristics of the building under the same conditions, so you can assess whether that door on the leeward side of the building is just as leaky as the window on the windward side. One thing you do find sometimes is people are trying to look at existing buildings with just, say, infrared thermography, and the danger of that is that actually the air tightness is a really important factor in how that building performs, and the comfort levels that are provided to the occupants. So by only using a thermal imaging camera, you are only looking at part of the problem, in just simply looking at it under normal conditions. So the door, the blower door creates a pressure difference, and we can put a number on that, and then it's an opportunity to then look at where the issues are within the building. So let's talk about the sort of results that we would potentially get. Now, there's two ways. When we're putting a number on what the air tightness of the building is, it's referred to in two ways. Now, before we started, we were having a quick chat about passive house, and they use one methodology for calculating the air tightness. But our normal methodology in the UK is something called air permeability. And basically, it is the fan flow rate, the fan has got to, the rate that the fan has to run at to achieve a 50 Pascal pressure difference, divided by the surface area of the building. And that's the sort of the where the air tightness layer. So in an existing building, what we're talking about there is the floor surface on the lowest floor, up the walls, and to the highest ceiling. So ignoring any intermediate floor voids. We can also talk about air change rate, and that's what's used when we're talking about passive house methodology. So it's a slightly different calculation method, but for the purposes of this discussion, just think of it as the flow rate from the fan divided by the volume of the building as opposed to the surface area. Now, depending on the building, they can be quite radically different things. So before we start to get into the detail about stuff, if you're a contractor and the client is saying, I've got an objective, an air tightness objective, you've got to be clear, first of all, what they're actually talking about. Because if you've got a nice square building, a cuboid building, those figures are going to be quite similar. But if you've got an L-shaped bungalow, that's going to have a much bigger surface area compared to the volume, and they're going to be radically different numbers. So the first thing is you need to know what your target air tightness is actually going to be. So that's the first question that you should be asking. The easiest way to tell quite often, because it's not a subject that people are particularly familiar with, is to look at the units that are against the number. So if you have an architect specification or some other form of documentation, look at the units that are at the end of the after the number. So air permeability is in meters cubed per hour per meter squared. So that's meters cubed per hour is how much air the fan is actually taking through it, compared to the surface area, which is in meters squared. The air change rate, you're looking at a volume from the fan compared to the volume of the building. So it's just expressed as how many changes of air does that building have per hour at that 50 Pascal pressure difference. So find out what the target is, first of all. Now, a key thing to bear in mind when we're talking about existing buildings is that there are things that are excluded from this test. Now, there is no standard protocol for the blower door test for an existing building, okay? There is a clear protocol for new build testing, and that's where most of the vast majority of these tests are done. The testers in the UK, I am a rare person in that I spend most of my life testing existing buildings, but 99% of air tightness testers will very rarely test an existing building. There isn't a clearly defined protocol for testing existing buildings. What I do is I prepare it to the standard protocol that's applied to new build houses. Okay. Now, what that means is I can then compare the results. So if I test, a listed building down the road, I prepare it in exactly the same way, covering exactly the same things as if it was a new build house. So those things are permanent points of ventilation. They are things like if there's a fireplace, that gets covered over. What we're trying to check for here is how the fabric performs in terms of the leakage, the infiltration, rather than deliberate holes that we have put in the fabric. So if you've got something like an open fireplace, you might think it's a bit crazy to cover that over, but life gets very complicated if we leave it all in. There's times when I do uncover them, but to check. But in terms of when I'm putting a number on a building, I cover over the fireplaces and prepare it exactly the as a new build house, because I can make that comparison then in terms of the air permeability or the air change rate. And then you add back in those things that are relevant to that particular property. So, for example, if I test a Victorian mid-terraced house that has two fireplaces, a fireplace in the dining room, fireplace in the front room, then you talk about the air permeability of the building, because if you did seal off both of those fireplaces permanently, that's what the background airflow would be. And you can allow an extra amount for what's happening with those chimneys and take it into account in the calculations and things that take place. So the building is prepared to the standard protocol. So in terms of benchmarks, we are comparing like with like in terms of building preparation. That's key. And you need to make sure that if you are commissioning a test on an existing building, that the protocol that you work to is clear to the tester, because, as I say, there isn't a set protocol. So ask them to prepare it as a new build property. So here are some some indications of the sort of scale that we're looking at. And I've got a mixture of new build and retrofit on here. I think it helps to understand the context as a whole. So the limit that we currently have for UK new build dwellings is an air permeability of 8. But a typical new build, sort of estate type major house builder house, 3-4 bed detached with gas central heating, is about 5 at the moment. So the smaller the number, the more airtight those buildings are. And in terms of most commonly approached airtightness standards, ACB level 2 is quite popular. It's used as a relatively realistic standard by a lot of designers. And in that instance, you're achieving an air permeability of 2 or better. So a number 2 is the maximum. It could be 1.5. It could be better than that, but 2 is the limit for the ACB level 2 retrofit standard. In terms of when we're looking at more airtight buildings than that, we're looking at ones that are taken through the passive house methodology, and Enefit is the passive house retrofit standard. And here we switch to different units. We switch to an air change rate, but for Enefit, you have to have an air tightness of no worse than 1 air change per hour at 50 Pascal. So that's quite a useful table to bear in mind when you're talking about, what client expectations are, and understanding when you're presented with that number, understanding the scale. If I had more time, I could go into, what the average is. The mean for UK dwellings is about 11.5. That's across the board, not looking at anything particularly, everything. That's sort of 400 odd dwellings, what it's coming out at. From my own experience, I've tested hundreds of existing buildings, and the pattern I'm seeing follows that 11-ish figure came from a BRE report that was done about 20 years ago. I still see the buildings I'm testing as fitting within that sort of normal distribution that they found, and a significant proportion of older buildings, pre-1900 buildings, come in at better than 10, and some are, can be as good as 5. It really depends on the building. So we see a wide variation, but that's another presentation anyway. Right, so what can be tested? Right, the answer to that is anything, right? So long as it's got an envelope of some kind. So this is a test that I did of a castle built in 1503, I think the castle was built. And this is up in Kintyre on the west coast of Scotland. So yeah, I don't feel I have tested cottages, I've tested thatch cottages, straw bale houses, new build, castles, you name it, you can test it, right? So don't feel that there is a limitation on it, and you would be quite surprised about some of the results that are actually achieved on those buildings. This came out just like it came out around the UK average for dwellings, actually, so it wasn't particularly leaky. Um, so yeah, you can test it. Don't feel it's limited as to what can be tested. Okay, so what I'd like to talk about now is what options have you actually got for when you do test buildings? So you started you've got this project spec, you've got an objective in terms of airtightness from the client or from the architect. So what do you do? How do you actually deal with that? So one of the key things, particularly where there's a very limited budget, is what needs to be done. One thing to bear in mind is when if a test hasn't taken place on an airtightness test hasn't taken place on a building, the building designer is guessing what should be done for that retrofit. Okay, they do not know the particular characteristics of that building. So if you have a client that say has 20 or 30,000 pounds or 40,000 pounds to spend on that house, it's not going to be, completely gutted. There's only going to be certain things that can be done within that building. And the building designer, the retrofit designer, in the widest sense, not necessarily, it could be an architect, it could be a retrofit assessor, could be a retrofit designer, does not know the specific characteristics of that building. So you might be being told to tackle the wrong things. So this issue of airtightness in existing buildings, there's a project which will remain unnamed that is in progress at the moment, where it covers three existing buildings, late 19th century, sort of terrace, end terrace type houses. And those three buildings, the results in those three buildings range from 28 to 7 in terms of air permeability. And you would clearly have to be doing very different things in those buildings with those different air permeabilities. But without doing that test, the person who is designing the measures for that retrofit may actually be doing the wrong thing. So, for example, the one that has an air permeability of 7 may actually need greater attention to the ventilation side. They're quite densely occupied properties. The one that has an air permeability of 7 may need more attention to the ventilation, and that should be maybe a greater emphasis. And the one at 28 needs probably more airtightness measures, even above, insulation, because it's that leaky, and would be difficult to heat in a whole shed load of circumstances. So bear that in mind, that if there isn't a test that the design has been based on, it's guesswork. Okay, so if the client has a specific objective in terms of final airtightness, if you don't know where you're starting from, you might not get there. So personally, I feel the pre-retrofit test is really important because it guides what needs to be done in the property, because it is guesswork without that. And really, if there is going to be a pre-retrofit test, it should be done as early as possible, ideally before the specification is done, because it guides the specification. There's no point in doing it once the spec's been done and then have to redo the spec. The most efficient thing is to test it before you start, and know what you've got. So that's typically done, quite often. If we talk about able to pay market, somebody's just bought a home, they're maybe remodeling it, and they're thinking about how they're going to approach the whole thing. So it's great to do it as early as possible. And it's really, the only time I wouldn't be particularly keen on a pre-retrofit test is actually if somebody's going for something like Enefit, so the passive house standard, because actually they're going to be gutting it completely. So it's a bit irrelevant, really, in that instance where the baseline test is, because everything is coming out. But the pre-retrofit test is particularly valuable where you have a limited budget and you're trying to target the measures to give the best return on energy saving so that you know you're only doing the things that really need to be done and you're really focusing on those things. So the pre-retrofit test is basically an airtightness test with thermal imaging. And for that, the building needs to be heated. Usually there's a heating system in there already. No work's been done, so it's sitting and you can heat it anyway. And that test is really helpful for you as a contractor because if you're present for that test, not only does it help the building designer, the designer who's speccing the retrofit, it helps you to understand where the weaknesses of the building are. So if you get an opportunity to be there, it's really helpful. It's really interesting to actually see that test taking place, and it will help you and help you to sort of convey the problems to your workforce as well. So an alternative time for testing is what I call the intermediate test. Okay, so you've got a target from your client that you've got to achieve. And how do you know if you've got there? And if you're used to dealing with new build housing, and you've seen an airtightness test before, you'll be aware that commonly the test is not done until everything is complete. All the kitchens in, bathrooms in, everything, and it's ready to be signed off. Now, to be honest, when you do a test at that point, you can't get to anything. All the plasterboard's on, you can't get to the airtightness layer. You are left with basically trying to address very superficial things. And what you really want to do is be able to check things when the airtightness layer is accessible. So we're talking about here, it's broadly at first fix. It's when the airtightness layer is complete. So you've got, if the windows are being replaced, when they're in, when the taping is in, the airtightness layer, it might be a plaster in an existing building. So when you've got integrity of all that and when all taping is done. And it's to check if anything has been missed at that point, really. However good we all do our best, but we do miss things. And it's of great value to do it at that point, and it's easy to sort out. And the other thing that does as a contractor is it gives confidence to the client at that point that you are broadly on target for where you are. So, they might have stage payment where they are saying they will release funds once you've achieved a certain airtightness. It really helps to give them confidence at that point about you're going to get there. Yeah. It will change slightly, after that, depending on what else needs to be done. But it tells you, if the target is 3, it tells you that you're about at 3 rather than it being at 7. So if you can only do one test on a retrofit, right, that is the test to do. Because for any of this to work, you've got to have a target, right? And you'll know if you test at that point whether you've achieved it and what you need to do to rectify it. And you've got an opportunity, because it's all accessible, to rectify the other things that need to be done before it all gets hidden. So it really de-stresses the situation at that point. So, you can be more confident moving forward when you're starting to put fittings and everything in that it's been achieved. There are other stages that tests can be done at. You can do a non-completion test. This tends to be the client might indulge themselves. They maybe are not going for certification, but sometimes they want to verify that everything is okay. So the sort of situations I've had where I've done that sort of test have been perhaps there's been an issue with the glazing, for example, and the glazing installers have been back in, carried out some rectification. So there are issues identified at the intermediate test, but it was it wasn't down to the contractor that was on site. The glazing was installed by, supplied and installed by somebody else, and they've come in and rectified it, and the client wants to verify that it's all been done properly. So that's an example of when that might be done. But if the client is going for certification, which, they're going to get a badge to say their retrofit complies to maybe AECB2 or Enefit, then there needs to be an on-completion test. So this is the same test as is done on a new build dwelling on completion. So the building is unheated, and it's purely a case of running the test properly at different pressures, so you get a compliant test. So in terms of, well, how does it break down? What do people actually go for in terms of tests? I have the whole spectrum of things. I have people who only go for an intermediate test. I have some people who only look at it initially, and then they're doing it a DIY themselves, and don't take any other tests after that. I have people where I've done 4 tests on some properties where people have been chasing a particular standard, and there has been a problem with the glazing, and it's going for certification. So it really does depend on the client. If you get a retrofit, if you're asked to quote on a job, you need to be clear about what the target is for airtightness, and you need to be clear about where the stage is, when it's going to be tested, because you've got to. What you don't want is the client saying, "Yeah, we'll have an on-completion test," but actually the one that's of greatest value for you is the intermediate test. I have one at the moment, which is a retrofit, where the client, the architect has specified he's done the detailing, but he's not been engaged to carry the project through. The householder is taking it over, and I've asked the architect, "What's the airtightness standard?" He said it's 3, and the client has been in touch and said, "Oh, we want a test doing on it. We've allowed for a test," and I've inquired a little bit more about it, and the client expectation was that it would be tested at the end, and maybe the architect hasn't explained the best way of doing it. That architect is familiar with my process. Maybe something got lost in translation, but the client is already part way through the project, and they have no assurance that they're going to get the airtightness. I've inquired about the measures that they've put in, and I think the problem in this particular instance is I don't think they've appreciated what's involved in achieving the airtightness and assuring that the airtightness will be achieved. It's not going to magically happen. You've got to have a complete strategy to achieve it. So don't assume that either the client or the architect is well informed about when things should be tested. You might have to spell things out about what you actually need to help you in a particular situation. If you have a clear target, you need to at some point be testing to confirm that you're achieving that, if nothing else, to ensure that you get paid at the end of the day, because that's one thing about the airtightness test. It's a clear benchmark. If you've achieved it, they should be paying you. So it's try and make sure you've got a clear strategy over what's required in terms of the target and what the testing is that has been allowed for, and stand your ground if there's no testing been allowed for. Okay, so I'm just going to talk through the sort of thing that you might see from these tests, okay, and how it then helps you as a contractor to go forward. So what I've got here is a thermal image that and the corresponding daylight image below. So the area that we're looking at, can you see my pointer on screen? Can you see my pointer? Yeah, good. Okay. So the thermal image is focused on this smaller area in the middle of the screen here. And this is a mid-19th century end terrace that we're looking at here. And the issue that we're examining is if we've actually got air coming through the wall into this intermediate void between the ground floor and the first floor, cooling it. We have air. The wall that's where the pointer is here, that's an internal wall, but that air that's in that intermediate void is then going behind the plasterboard and cooling that internal wall. So we've got a whole combination of things there that you may not necessarily expect when you're in the building. There might be an assumption that if we line the walls, it will be fine. Well, we don't need to bother with the intermediate void, but this really shows that we've got some issues in this particular property. And this particular test was done with the person who's responsible for the project on this property. And it helped to inform their strategy for moving forward on that. So you work around the whole of the building and identify where the issues are, as well as putting the number on how airtight the building is. So you can see where it is on the scale and where the issues are within the building. And then the designer can go away and specify the detail of what's required based on the findings from that test. So here's an example of an intermediate test. This is on it's a property that's being upgraded in stages. It's a 1930s bungalow, and basically they've just done the kitchen so far. So this is the rest of the house they're living in, and they're doing it room by room. It's a builder's own home, and they're using it as a way of upskilling themselves. Got a superb airtightness result on that one room. I basically separated it from the rest of the building, came in at something like 0.7. In terms of air change rate, it's quite a cuboid room, so similar air permeability. So a really great result that they've got. And we've got some examples on here that we can see of use of membrane. So we've got membrane on the ceiling. We look at the ceiling there. They've replaced the door. We've got taping around the door. Here on this wall, we've got an insulated plaster. In this case, it's diathanite. That's a lime-based plaster with pulverized cork in it. And at the junctions, what they've done, the black stuff is a paint-on airtightness layer. This is great, the paint-on stuff, because what it's doing is it works in the same way as tape, but you can get into those nooks and crannies so much more easily. So, for example, if you are doing around joists in a floor, the paint-on airtightness is superb. And it's a lot easier than trying to use origami for getting tape into difficult areas. So this is a good illustration of what we're seeing. And thankfully, I'm not really seeing any airtightness issues on this particular area. But that's the sort of thing that we're doing. We've put some heating because it's part way through. You have to put some temporary heating probably into the space that you're testing, usually overnight, or we time the test is timed for later on in the day. But you heat the space temporarily, and that allows the use of thermography. Now, you go around and look at all of the issues. It's easy with a thermal imaging camera to record those issues, and you've got them for future reference. Ideally, what you do is you rectify everything while the tester is there. So you work around the building, following the tester, doing all the remedial work that's required, and then the tester goes back round the building and checks it's all okay. That's the normal method that I use, and I would expect anybody else that's doing an intermediate test to take the same approach, so that by the time they leave, you're happy that you've got where you need to be, or if it's something more major, you have a strategy determined for what you're going to do about it. So that is the test that really is of greatest value. On completion and for compliance, there's very little to say about that. It's a really boring test. But it's a case of that's what's required in the compliance test. You've just got to do it to achieve certification. So yeah, as I say, it's boring, that bit. Okay, so in terms of preparing for a test, okay, so these are things that apply to both new build and retrofit, okay? So if you're in both markets, bear this in mind. Key is understanding the objectives. Quite a few clients say, well, I just want an energy efficient building. I just want something that works. I want it sustainably. I want it eco, right? I have had some dreadful situations I've had to deal with. The particular example I'm about to give you was a new build property, but it cannot. It also applies to retrofit. The client conveyed their requirements to the architect who designed the building in terms of energy efficiency. They had every piece of renewable energy technology you can possibly think of on this building. But when the client said, I want it low energy, I want it sustainable, the architect didn't hear that. They heard their version of low energy and their version of sustainable. Yeah. So what people say and what people hear are different things. The only way to get around that is to quantify things, to put a number on it. So in that particular instance, the architect was clear. He said, yeah, he wants something that's eco, but wasn't any more specific. Talking to the client, at a separate time about it, a 5-minute conversation with him, I could tell you what the air permeability was that he was after. Basically, he said, I want it airtight enough to justify mechanical ventilation with heat recovery and for it to work effectively. And what that means is, we're talking about an air permeability of no worse than 3 and ideally better than 1.5. And what he actually ended up with was about 8. And that's on a new build. And unfortunately, I also have to test quite a number of houses where people have had a retrofit done, and I'm only called in afterwards because they haven't got what they expected from their project. The common factor all the way is people do not put a number on it. And it is quite hard to do that sometimes because you're trying to translate somebody's thoughts, somebody's view about what they want into a number, but it's a lot harder trying to get your invoice paid at the end if they haven't got what they want, right? So it's worth quite a bit of hassle initially to work out what the client is after. And if the architect or the retrofit design person has not given you a target to work to, unless it's like very relatively trivial things and it's only part of a house, I would be concerned. Try and get a number because you then know what you're working to. And if you don't know what you're working to, you won't get to where you need to be. And everybody will end up unhappy. So if you only take one thing away from this presentation, understanding the objectives and quantifying it is critical to the success of your retrofit project. When we're thinking about the process as a whole, the thing to bear in mind that it's all collaborative. Okay, so the people who are successful at retrofit are people who work well with others. So, you work with the designer as a contractor. They value your opinions about what's practical to do on that building. And you can feed into that process. I know the way that we normally work, is it's you're presented with a project and that's it, and you have no say in doing stuff and how it's done. but the most successful retrofits are where the contractor's opinion is valued and he feeds into the design process. So that pre-retrofit test is a really good opportunity for, you become aware of what the building is like, the architect and the designer becomes aware of what's happening in the building, and then it becomes almost like a joint journey for understanding what's needed and what can actually be done. So I can give you an example of this. It's a 1960s detached house where the contractor was involved in the project from the outset, but the designer made a decision to leave the bathroom in place, the fittings in the bathroom in place. Everything else was virtually gutted out of the building, but that was a little bit of a step too far in terms of costs with the client, and the designer made a decision that that wasn't going to come out. There were key leakage areas. I mean, in that first drawing I put up, there were key leakage areas, related to surfaces, waste pipes, soil pipes, that sort of thing. And in the end, the building didn't get to the required standard because the contractor could not get behind some of the fittings to do the right level of works to stop the air ingress in those locations. And that was the key learning point from that building, that the architect was relatively inexperienced at that standard of building, and they hadn't appreciated the burden that they were placing on the contractor by making that decision. A more experienced designer would have probably appreciated the situation better and then discussed the situation more with the client. But you're in retrofit, once we clearly experience is important, but once you're established in retrofit, it really is aim for a collaborative process that you're working with the client and the designer to achieve what the client's requirements actually are. Important intermediate test. I mean, I think I've already covered this probably at length, but it really is so important because it gives you the opportunity to snag at the minimum cost involved and takes the stress away from you as the contractor. And it shows the client that you are where you need to be in terms of the level that's required. And just to emphasize again, that pre-refurb test, if it happens, you really know what you're working with then. So try and get to that test if it's taking place. So that's what I've tried to cover. And I'm happy to now talk about tape as much as you possibly like. And I will stop sharing my screen.
Thank you, Diane. That I just through the whole of that is that it's just that question is that, well, first thing is the obvious is that I feel the majority of retrofits in the UK will require an air test prior to anything. But the biggest thing is that I think it's this understanding of objectives. And trying to convince householders to retrofit in the first place is hard, but their understanding of what retrofit is, and in terms of like, I just want a comfortable home, I want a home that doesn't cost too much to heat. And it feels like our current process of retrofit assessment doesn't quantify that specific house requirement. It just looks at a set of like a procedure, a set of standards that, well, we'll do this, we'll do that, we'll do the other, and you'll have a warm house. And it's just that to me it's a no-brainer is that this needs to be built into the retrofit assessment, or it certainly needs to be something that's considered what's the word, properly at that point when they enter a property, is that the level of retrofit is going to be more than just just looking at kind of the obvious things, and therefore an air test needs to be carried out.
I think there's sort of a couple of points just to emphasize, sort of following on from that. One is that, I was talking about the architectural building designer being there for an initial test as well as the contractor. Um, but also the client being there is absolutely brilliant, right? Because what that does is it shows them what the issues are with their property, whether we're talking about a landlord or a social landlord or uh, just a normal householder. Um, it convinces them they haven't got a clue about airtightness usually to start off with, and to actually be able to feel what's coming through a wall or to show them what's happening is great. And it's great as an engagement tool and works very well with architectural professionals as well, because they're sometimes having to convince the client to spend, X thousand on something. And it shows, it makes it tangible to the client. And that's an aspect I haven't really brought out in the presentation. So it's really good for client engagement and getting them to buy into particular works. Rather than spending an extra £5 grand on your kitchen, put that into tapes and airtightness measures. That sort of discussion. So actually being able to engage the client on that. The other thing to emphasize is that if we're talking about the funded market, so what people that are operating within sort of a PAS 2030, PAS 2035 structure, then when you look at PAS 2035, there is a requirement in there to assess the air tightness of the building, where the measures cover are likely to improve the air tightness. So if you're putting new windows in, or internal wall insulation, or anything significant, there's a requirement to assess the air tightness, and for good reason. Though I have to say, people are not doing that at the moment. So in my mind, there's a risk, or it's not being done routinely. There is a risk in people not doing that, which is why I'm not going to plug my course, but I can email if anyone's interested. I can send you details of. I've developed a course to basically try and train up more people to do what I do. People who are carrying out retrofit assessments, it's a desk-based thing. They don't have necessarily any practical experience. There's nothing covered in the training in terms of practical in-buildings experience. So you could have somebody walk off the street and become a retrofit assessor without actually going in a building and assessing or understanding a building properly. To me, that's a problem. And I'm wanting to address that through this particular course that I'm pitching to community-based organisations for people that work with them, either in the organisation or as associates to the organisation. So I think it's a real problem, that is, and time bomb is an overused word, but it could be two words probably. But I think that is a real problem, because some of the issues that we're seeing regarding ventilation and mold are occurring because people are assuming the building is maybe leakier than it actually is, and the wrong measures are maybe being put in even on a limited budget. So I think we should be testing more pre-retrofit routinely, which are of the properties that are being done under PAS 2035.
Absolutely. I couldn't agree more. You just actually reminded me, one of the issues with trying to convince people to invest in retrofit, as opposed to so those things you can see, like you mentioned, like the kitchen or the kitchen island or the bifold doors, and they're more than happy to co-invest like 10,000 or whatever in that. But when we talk about retrofit and we talk about £10,000, they're very reluctant to invest that money because they can't see it. But immediately you've hit on something there that's kind of, well, the light bulb moment for me is that, do an air test with thermography. You got the client there sat in their own house, seeing exactly where they're losing all their heat. And, if you're looking for an argument to invest in retrofit, that I don't think it could be any more pointed than that.
I have a classic one on that. There was a test I did in the winter gone, which was in a very nice West London house, right? 4 stories. They'd converted the basement. It was one of those, cinema room. It was a beautiful house. But I think the guy was a fund manager. He was not engaged initially in the process really, but he'd seen an article about it, and he was paying me to do a test. But he got really excited when I sent him round the corner from the house, and I put smoke into one of the second floor bathrooms, and the smoke poured out into the street. And I told him that actually 20% of the airtightness of that building was going through that bathroom. He said his kids, who lived on the top floor, always complained it was a bit cold up there. And then I left a £40 roll of airtightness tape with him, and he could sort it out himself, right? And that's the sort of thing, that's an example of that householder. All I'm doing is I'm giving them the confidence. Householders, they're being sold to by all sorts of people. Yeah. Everybody's trying to flog them something, and they don't know whether what they're going to told to do that is that the right thing. They're after something. They need confidence. And the thing about a test like this, most commonly when people ring us, we're thinking about putting a heat pump in. Will it work in our house? And the airtightness is going to be a key part. A heat pump will work in anything, but the problem is it's how much it's going to cost you to run. And airtightness is an important part of that whole process. And what something like that pre-retrofit test does is it gives the client confidence and to know what the issues are in their home. They understand it. It's like going to the doctor and having a general checkup, and they say, yeah, you're all right. Oh, you're a bit overweight, few diabetes, pre-diabetes, adjust your diet. It's that sort of thing. It gives them confidence to then make future decisions. So it's a wonderful tool to use. And I see it so many times in action that people feel more confident to move forward, whatever it is, whether it is just to stick a heat pump in because actually it's a reasonable air tightness, or they want a heat pump anyway, but they're prepared for the increase in fuel bills. They can move forward. So it really does help the able to pay market, give them more confidence for actually making those changes.
Yeah, yeah, yeah. I can see that 100%. Does anybody have any questions? Your microphones are on from my perspective. If anybody wants to ask a question, don't go very quiet. No, talking is permitted.
Well, I'm happy to pick up on questions afterwards if anyone wants to pick up, wants to get in touch with me. That's fine.
That's great. Okay. Well, I think in that instance, I think we'll close it there.